Hi everybody, this is Eduardo Suarez. This video is part 2 of a series of videos dedicated to iRPickTool. On part 1, I gave you an introduction to iRPickTool. I explained you that there are two option packages, iRPickTool Basic J944 and iRPickTool that is the plug and play option that is a J945. We're going to discuss only the plug and play option, since this option package has all the TP programs and caret programs already configured for you, reducing the effort of configuring the workcell. We're going to start by creating a new workcell. We're going to go to Windows, Start. We're going to select Funnel Robotics, and we're going to select Handle Pro. We're going to create a new workcell. We're going to give it a name. We're going to press Next. We're going to create a new robot with the default Handle Pro configuration. We're going to press Next. We're going to select the latest version for the software. We're going to select Handle Tool. We're going to press Next. On the robot model, we're going to select the M2IA3SL. We're going to press Next. We're not going to select any motion groups. We're going to press Next. And here is where we have the robot option packages. So for that, we're going to look for iRPickTool. And over here, we're going to select the iRPickTool J945, and also we're going to select the iRVision J946. We're going to do a few more selections. We're going to select the efficiency tool. We're going to select the motion package. We're going to look for encoder, and we're going to select the Ethernet encoder R762. And also we're going to select the Advanced DCS package. And we're going to press Next. Here we're going to have a summary of all the option packages to be installed. And we're going to press Finished, and the workcell is going to be created. Once we have the workcell, we have the first robot already created. We're going to select the robot. We're going to right click. We're going to go to Properties. First thing we're going to do, we're going to change the name. We're going to call it Robot 1. And we're going to change the position of the robot. And we're going to press Apply. So this position is going to match the position that we have in the previous workcell that we created with using the iRPick Pro. We're going to close the property window. We're going to select the Robot Controller 1. We're going to right click, and we're going to add another robot controller. And this time we're going to add a robot clone. On this window, we're going to change the offset. We're going to select minus 1500, and we're going to press OK. Now we have the second robot created. We're going to select the robot. We're going to go to Properties again. We're going to change the name, and we're going to verify the location, and we're going to apply the changes. One of the things that you have to consider is that the both robots may have the same software revision for the firmware and the package revision. If you want to look for that, just select one of the robot controllers, open the Teach panel. Over here, press the status key, select type, select version ID, and on item number 7, you're going to have the version for the firmware and the package version. Another way you can access this same information, you can select menu, next, status, and version ID. We're going to continue creating the workcell. Now we're going to add the conveyors. We're going to select fixtures. We're going to right click. We're going to select add line. And we're going to select machine library. You're going to get a list in here. And from this list, we're going to select the generic infeed conveyor. And we're going to press open. We have the pop-up for the properties on the infeed conveyor. On the general tab, we're going to select the name and we're going to call it infeed conveyor. We're going to change the color. We're going to select green and we're going to change the location. And we're going to press apply. We're going to expand the infeed conveyor. We're going to select conveyor belt in. We're going to go to properties again. We're going to change the color. We're going to unlock the location values. And we're going to change the location again. And we're going to press apply. So now we have created the infeed conveyor. We're going to do the same with the outfeed conveyor. Noticing here that the infeed conveyor has a pole, and the center of the pole is the origin for the tracking frame of the infeed conveyor. So later we're going to change that location. We're going to press OK, and now we're going to create the outfeed conveyor in the same way. We're going to select fixture. We're going to go to the machine library. This time we're going to select the generic outfeed conveyor. It's saying that the tracking encoder changes for schedule number 2. We're going to press OK. We're going to change the name. We're going to give it a different color. And we're going to change the location. We're going to press apply. We're going to expand the outfeed conveyor again. We're going to go to the conveyor belt out. We're going to change the color. We're going to unlock the location values. and we're going to change the location and the scale. And we're going to press apply. In this way, we have the infeed and the outfeed conveyor exactly the same way that we have on the previous process we created with the iRPick Pro. One more thing we're going to do, we're going to select the infeed conveyor and we're going to select the part carrier infeed. We're going to right click and we're going to go to properties. We're going to select the general tab and you're going to see here that the tracking schedule number 1 is associated with the robot controller number 1 on the infeed conveyor, and what you see here in brackets is the encoder numbers. It's going to be encoder number 1. Similarly, if we go to the outfeed conveyor, we select the part carrier outfeed, you're going to see that in this case we have the tracking schedule number 2, and in brackets indicates the encoder. That's going to be encoder number 2. Now we're going to go back to the robots and we're going to configure the NRAM tooling. We're going to have two NRAM toolings. One of them is going to be the pointer that we're going to use for teaching the tracking frame on the infeed and the outfeed conveyors. Also, we're going to use it for teaching the tracking frame on the vision system. And eventually, if you are using a tray, this NRAM tooling is going to be used for teaching the frame of the tray. And the second NRAM tooling is going to be the suction cap that we're going to use for picking and placing the parts. We're going to select Robot Controller 1. We're going to go to the Robot 1. We're going to select the tooling. And we're going to select the user tool number 9. We're going to right click. We're going to go to Add Link. And we're going to select CAD library. From the CAD library, we're going to select the NRAM tooling. We're going to select the pointer. And we're going to press OK. You're going to see that the pointer is already attached to the faceplate of the robot. We're going to select the Link CAD tab, and we're going to change the scale to 0.5. And we're going to press OK. Now we're going to select the user tool 9 again. We're going to go to properties. We're going to select the user tool tab. We're going to edit the user tool, and we're going to change the Z to 89 millimeters, and we're going to change the W to 180 degrees. And we're going to press apply. So in this case, this is 4-axis robot, and we're going to use the direct entry method. You can use this one if you have all the data from the CAD drawings. Another method that you can use for teaching the user tool, if we select the robot again, we're going to open the teach pendant. We're going to select menu, setup, frames, and we're going to select the tool frames. If you are not in the tool frame screen, you go to order and select the tool frame. So in this case, we have on the user tool number 9. We're going to go to details, and over here, if you just want to apply the direct entry method, you just set the values the same way that we did on the Roboguide. Otherwise, you can go to method and you can select the 2-point plus Z method. This is method number 4. So if you use the 2-point plus C, what you're going to do, you're going to select the approach point 1. You're going to have a pointer that's going to be your reference, so you're going to align the environment tooling with the pointer that's going to be on a fixed position. You're going to press shift and record. Then you're going to have this value here that's going to be recorded. You're going to select the approach point 2. In this case, the only thing that you can do is just rotate 90 degrees the axis forward of the robot. And again, you're going to align the environment tooling with the pointer that is in a fixed position. And you're going to repeat the same method. You're going to press shift and record. This is going to be recorded. And then manually you're going to change the C height. And you can also change the WU. So these are the two methods that we're going to use. Either you go with a direct point entry, or you use the 2-point plus C. And this is exactly the same method we can use for the user tool number 1, that is going to be the suction cap. Now we can set this user tool to active. That's going to be user tool number 9. We're going to repeat the same method on the robot number 2. I'm not going to show you that. I'm going to just make the changes. Now we're going to select the user tool number 1. We're going to select add link, and we're going to select cut file. We're going to select a cut file model that I already have. And we're going to reposition the part. We're going to zoom in. We're going to take the measurement tool, and we're going to check the distance. And we have 70 millimeters. So we're going to go back to the user tool. We're going to close this. We're going to open that again. We're going to go to the user tool. We're going to edit, and we're going to select 70 millimeters. We're going to change the WU to 180. So in this way, we have the user tool number 1. That's going to be our suction cap. Now we're going to open the teach pendant. We're going to select menu, next, system, motion, and we're going to set the payload schedule. So we have two already defined here, the empty gripper and the full gripper. We're going to select the number 1. You're going to go to detail. We're going to put the payload in kilograms. Let's say this is going to be 700 grams. We're going to set the payload center. This is going to be 70 millimeters. That in centimeters is going to be 7 centimeters. And also we need to put the moment of inertia on the X, Y, and Z. That we can get this information from the CAD files. We're going to go back, and we're going to do the same with the schedule number 2. That's going to be the full gripper when we have the suction cap with the part. We're going to go to details. We can say that this is going to be 1 kilograms And again, the center on the Z is going to be around the 7 centimeters. And again, we need to do the moment of inertia for the X, Y, and Z. And with this, we have configured the user tool number 1 and user tool number 9 for the robot number 1. We need to do exactly the same for robot number 2. We're going to continue with the workcell configuration. At this point, we need to start looking at the workflow that I mentioned before. The first point in the workflow is setting up the IP addresses for all the robots. And here we need to make some considerations. First, we need to decide what port we're going to use for the Ethernet network. If you look at the CPU board on the robot controller, and also this depends on the robot controller that you're using, you're going to see that there are two RJ45 connectors, the CD38A and the CD38B. These are the two Ethernet connectors that we have on the robot. Also, you're going to see there is another connector on the bottom of the board. I'm not sure if that's showing on this picture in here, but maybe this one in here. So this connector is for the geeky camera. Don't connect your Ethernet network over here, it's not going to work. In a normal case scenario, you're going to have a PLC connected to the robot, and also you might have the plant network connected to the robot. For that case, we normally use port number 1, and the reason for that is that the connection is optimized for high volume traffic. So in a normal case scenario, you're going to have a port number 2 for the Ethernet connection between the robots, but this is entirely up to you. The important thing that you want to consider is that you want to have the connection between the robot isolated from any other devices, so the robot can communicate between each other at high speed, and this is critical for this kind of applications. Another thing to consider is that you're going to have a robot that's going to be the master, and all the other robots are going to be slaves. So now, who is going to be the master is up to you. In our case, we're going to consider that the master robot is going to be the one that is upstream on the infeed conveyor. And in this case, this is the one that's going to have the line tracking interface board for the Ethernet encoders. One more thing is that if you're going to have a camera for the infeed conveyor sensor, you also want to connect the camera to the master robot controller, because you want to make sure you are going to have the most accurate value for the pulses from the infeed conveyor's encoder. Otherwise, if you connect the camera to any other robot controllers, you're going to have a delay on the encoder pulses count due to the Ethernet communication delay. This communication delay is going to be in the order of milliseconds, but if you multiply these milliseconds by the speed of the conveyor, this is going to give you a few millimeters error in the position of the part detected by the camera. To summarize, the master robot controller is going to be the one that's going to be upstream on the infeed conveyor, and we're going to connect the line tracking interface and the camera to this robot. One more thing to consider is that all the IP addresses you're going to assign to the robots, they must be in consecutive order, and the IP address for the master robot controller must be the lowest value. This picture is an example of how the Ethernet connection is going to look like. We're going to have an Ethernet network on port number 1, where you're going to have the plant network, the PLC, etc. connected to this network. We're going to have another Ethernet network on port number 2. This is going to be an isolated network only for the robot controllers. We're going to have the infeed conveyor flow in this direction. And we're going to have the master robot controller and the slave controller, each one with its own IP addresses started with the lowest value on the master robot controller. We're going to go back to Roboguide and we're going to configure the IP addresses for the robot controllers. In our case, the product on the infeed conveyor flows from left to right. So we're going to consider that robot controller number 1 is going to be the master and robot controller 2 is going to be the slave. Since we are in Roboguide, we don't have any PLC or plant network connected to the robots. So for simplicity, we are going to use port number 1 for the Ethernet network. We're going to select robot controller number 1 and we're going to open the teach pendant. Over here on the top, you can see the robot controller where you are connected right now. We're going to press menu. We're going to select setup and we're going to select host communication. On the setup protocols, we're going to select TCP/IP and we're going to select details. We're going to give it a name for the robot. Call it robot 1. Next, we're going to select the port. Here you can go to port and either select port number 2 or port number 1. And in our case, Roboguide has already assigned an IP address for us. We're not going to change this IP address, but we're going to follow the rule that the master robot controller is going to have the lowest value. Then you can assign the subnet mask, and we don't need to assign anything else. After we assign the IP address, we need to reboot the robot controller. So one method that we can use for that, we can select next, and we can select initialize. And in that case, if we say TP/IP initialize, we modify the root network configuration, and we're going to press yes. Here it failed because we are in Roboguide, but it still is going to work if you do that on the real robot controller. In the case of the LR-made robot controller, you cannot do that. You need to cycle power the robot. Alternative, another way to do that is selecting function. We're going to select next, and we're going to select cycle power, and we're going to set yes. Now we're going to assign the IP address for robot controller number 2. I'm going to select the robot controller. Make sure that you are in robot controller number 2. Select menu, setup, host communication, TCP/IP, go to details. Make sure that you are selecting port number 1. We're going to change the name for the robot. We're going to call it robot 2. The IP address is already assigned. We're going to follow the rule. This is going to be number 3. And we have already set up the subnet mask. So again, we're going to cycle power the robot controller. In this case, because we're not changing the IP address, we don't need to do that. One more thing that we can do, we can go over here and on the host name, we can select the robot number 1. We can assign the IP address. And with robot number 1 selected, we should be able to ping the robot. And you can see that they ping success. So that means that we have a communication between the two robots. And with this, we have completed step number 1 on the workflow, that is setting up the IP addresses for the robots. We're going to finish with part number 2 of this video over here. Still, there is a lot of material that we need to cover, and this is going to take a few more videos to finish with iRPickTool configuration. To summarize, we have covered the first step on the workflow, that is setting up the IP addresses for the robots, master and slaves. This is a fundamental step seen from here. The next step we're going to cover on the next video is going to be setting up the right communication, and from there we can set the encoder connection and be able to transfer the encoder pulse counts for the infeed and outfeed conveyor from the master robot controller to the slaves. I hope this information has been useful for you. Just be patient. iRPickTool is an advanced topic that involves setting up any individual component that you have in your workcell.